Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about Monte Carlo Simulation. This topic is based on a tech blog with the title Monte Carlo Simulations: Separating Signal from Noise in Sampled Success Metrics, written by the data science team from Shopify. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Shopify is a leading e-commerce platform. It empowers businesses of all sizes to create, customize, and manage their online stores. With its user-friendly interface and robust features, Shopify allows merchants to set up their stores quickly and efficiently. It handles everything from product listings and payments to shippings and marketing. To offer various features to their merchants, Shopify built a marketplace called the Shopify App Store, where merchants can find useful apps and plugins to customize their store. The Shopify App Store is an integral part of the platform, and these apps cover various functionalities, including marketing, sales, customer service, analytics, and more. Merchants can browse through the App Store to discover tools that meet their specific needs and objectives. This further extends the capabilities of their Shopify stores. Because these apps are developed mostly by third-party developers and may vary significantly in terms of their handle on safety and security. To maintain the health and quality of this marketplace, the company sets a high standard of app quality. It has over 200 requirements focused on security, functionality, and ease of use. Each app needs to meet these requirements to be listed, and the company has various manual and automated app review processes to ensure those compliance. However, apps constantly evolve and update over time, and the team wants to continuously evaluate how their review processes improve the quality of the App Store. Therefore, they need to understand how many requirements the average app violates. Over time, the team aims to make improvements to the review process to reduce this number. Now that we've understood the business problem, let's dive into the data science side to see where the challenge lies in and the solution to that. First, we need to understand what is a success metric. A success metric is a quantifiable measure used to evaluate the performance of a particular action, process, or initiative in achieving its objectives or goals. In this above example about Shopify App Store, the question about how many requirements does the average app violate is a success metric for the team. Having a success metric is crucial for the team and overall company, as it helps to quantify the progress and assess whether objectives or goals are being met. As one type of success metric, a sampled success metric is a performance measure or evaluation criteria that is calculated from a sample or subset of data rather than the entire population. This approach is used when it's impractical or resource intensive to analyze the entire database. Instead, a representative sample is selected, and metrics are calculated based on that sample. The key difference between sample success metrics and standard success metrics lies in how they are derived. Standard success metrics are calculated directly from the entire dataset, providing a comprehensive view of performance across the entire population. One example is the sales amount. Another example is the daily active user, where these things can be directly calculated for the entire population. In contrast, sampled success metrics provide an estimate of performance based on a smaller subset of the data. One example would be customer satisfaction score, where it is impractical to have every customer provide such response. While sampled success metrics may not capture the full complexity of the dataset, they offer a cost-effective way to assess performance and make informed decisions, especially when dealing with large and complex datasets. In the example mentioned above for the Shopify App Store metric, how many requirements does the average app violate? This requires the team's effort to audit each app through more than 200 requirements as listed, which would incur very high operational costs. Therefore, to build up this metric more realistically, it would be preferable to sample a subset of the stores through the audit each week, and then calculate the observed number of requirements the average app violates to represent the full population's behavior. Let's call this success metric shop issue rate for simplicity. To develop the sampled success metric shop issue rate, there is a natural trade-off involved. The more samples the team have, the more accurately the metric represents the true success metric, indicating low variability. However, a higher sample number would incur extra operational costs. This creates a delicate balance in choosing the right number of samples to meet the business need. This is where Monte Carlo simulation comes into play. So, what is Monte Carlo simulation? Monte Carlo simulation is a computational technique that is used to model the behavior of complex systems by generating random samples from probability distributions of uncertain inputs. Its applications spans various industries, including finance, engineering, healthcare, and beyond. In finance, Monte Carlo simulation models investment scenarios and assess risk. In engineering area, it simulates the performance of structures and systems under different conditions. Essentially, Monte Carlo simulation provides a powerful tool for decision-making by generating insights into the range of possible outcomes and uncertainties associated with the complex system. For Monte Carlo simulation to be used to facilitate the decision-making regarding sampled success metrics, there are several steps involved. The first step is to define a simulation metric to represent the variability of the sampled success metric. Through each Monte Carlo simulation, it mimics how the simulated sample success metric deviate from the real success metric under a hypothetical environment. With this simulation metric, it can easily demonstrate the magnitude of such variability and make performance comparisons straightforward. For example, for the shop issue rate, the team may want to know, assuming we decrease our shop issue rate in the population by a given amount per month, in how many months would our metric decrease? The earlier a sampled success metric shows a decrease, the more accurately it reflects the actual success metric change. So, one of the simulation metrics could be 1 month decreases observed, and this can be leveraged as one simulation metric. Once a simulation metric is defined, the second step is to define the distribution to draw to make the Monte Carlo simulation. For the context of the shop issue rate, because each app may have issues arising from any one of the 200 potential criteria, and assuming meeting or not meeting each criteria may be considered an independent event with binary output. The number of issues an app can have can be represented by the Poisson distribution. We know that one of the parameters we need to set is Poisson's lambda. The lambda parameter represents the mean and the variance of this distribution. We can also assume that there is a real change in the actual shop issue rate every month. So we need to specify the percentage by which this lambda would decrease every month. With this above hypothetical market environment being set, we then need to determine how many random audits we are going to conduct every week. This is our sample size for the manual audit on a weekly basis. As the sample size increases, so does the cost of collection. This number is crucial for the stakeholders as it helps them to understand the trade-off between the uncertainty of the metric and the cost of collecting the data. Now, with all these above parameters being set, a Monte Carlo simulation can be conducted to observe how the simulated metric would change under this one hypothetical environment, and with this one provided sample size. Such a Monte Carlo simulation can be conducted over any hypothetical environment. So now, a massive simulation can be conducted. In this massive simulation, it can mimic many hypothetical situations, such as the issue rate decreasing but at a different magnitude, to understand how the sampled success metric could quickly capture the true market dynamics under a specific sample rate. With these simulation results, the team can clearly express the uncertainty trade-off in terms of the stakeholder can understand and implement. For example, the team can analyze the results and say that with an additional 50 audits per month, it would yield a quantifiable improvements in the uncertainty. These insights can enable stakeholders to make an informed decision about whether the uncertainty is worthy the additional expense. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how the data science team from Shopify leverages Monte Carlo Simulation to develop their sampled success metrics. We discussed what are sampled success metrics and associated trade-offs needed to build them, and how Monte Carlo simulation can be used to inform decisions. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.